Welcome to the second part of our DidgetBrowser tutorial. In our previous video we showed you how to import a bunch of files or create a bunch of test digits using our DidgetBrowser. We're going to bring up the same DidgetBrowser. We'll see the digits that we created before, but now we're going to show you how to use the database features. So on this database tab, here we have a few windows here for some table definitions and some table instances. We haven't created anything yet, so let's go over one of the folders we give you is this databases tab, in which we define some database tables as well as have a bunch of CSV files full of just random data that we've created. For example, this friends.json is a simple table that's we call friends, that lists each column name, what type of data it is, and the max length it has. We also have a customers JSON, which has a few more columns in it. This one has 10 columns, including social security numbers and emails and phones, zip codes and things. And so, but we also combine those two into a single tables JSON, so we can just drag and drop that definition over here on our definition window, and it'll pull those in. And so you see we have our friends with 6 columns, customers with 10. If you just double click, it'll pull them up, you can add any columns you want, or move them around, or do whatever you want to edit this definition. But the JSON's a quick way to pull in some definitions and start using them. So now that we've created a couple of definitions, let's import some data and show you how we can create some tables from that. So here we have a set of CSV files. I've just sort of numbered these. So for example, this 2M10X means there's 2 million rows in this, and it's 10 columns wide. This 250K 6X is got 250,000 rows in it, and it's using the 6 columns. And that just corresponds to these two tables we've defined. So if I grab that 256K with 6, I'm going to put it on my friends, and it will now import all the CSV data. You can see over here it's just got names, addresses, cities, states, phone numbers, and emails. And so we import that. It just takes a few seconds to import. And now I have a table that has 250,000 rows and 6 columns. If I just double click on the instance, it'll do a select all against there. And so there's all my data in all the rows. I can sort each column according to either ascending or descending values, or we can just go with it back to the default and select all. Now we can give you a more detailed view of that. If you right click on a table definition or a table instance, it'll let you create a table view. Here's where we say, we want to see just a part of the table. So for example, we want people who live in states that start with the letter N. So we want to see everything. Maybe we don't want to see their email address, and we say where the state starts with the letter N. So now we have a view that's associated with that table. Again, if we click on this, we see everything, but if we click on just this, now we only see the 39,632 rows that have an N for the state. Again, if we sort, you see we go from North Carolina, NC, to NY, which is New York. Again, out of our 250,000, only 39,000 had that. Let's grab a bigger table. So come over here and grab our 1,000,000 row with 10 columns. Copy that into the customers. Say we want to import everything. This one takes about 15 seconds or so to populate all our 1,000,000 rows. And we should now have a table instance of 1 million row table. Double click on it. There's all the different information. Just like before, we can sort each column ascendingly or descendingly, and just like before, we can create a table view. Now let's say we want it to be a little more selective, and we want people with a LA in their name, and they live at an address that has 24 somewhere in the address. Okay, so we want to see everything, and to make that, so we want the name to contain LA, and the name, actually let's make that an OR. So we want to see OR, the address contains a 24. We say OK. Now if we click on that, we should see all the addresses. So if there's an LA in the name, we won't see we may not see a 24. I guess we could have both. This is an OR operation. But of our 1 million rows, just slightly under a tenth of them, or 96,000 of them, met one of those criteria, an LA in the name or a 24 in the address. Again, very fast to do all these queries. We can narrow it down very, very quickly. We're using our tags digits to create this table. So this table is just made up of a set of columnar key value stores, basically. That is really what our tags are. So we can come here and we dedupe all the data. So if I right-click on the column header and say, show me all the different values, you see that there's 1,154 unique names that were used in our data generator. Quinn happened to be the most common one, and Breyer happened to be the least common one. But again, we have 1 million uses of various names, and tells you how much each one was used, how many rows. So if we did a specific query and said, find us all the rows where the name equals Joseph, we would expect to get 1,080 rows back from that. We can do some filtering here and say, let's say we want to find all the names that started with the letter J. So we could do a J. Want to go a little JA. There's 23 different names that start with JA, and 20,084 rows would match a query for all names that started with JA. And so it's just a quick way to aggregate information and to create queries based off of what we want to see in our tables. And so that's kind of how, in a nutshell, our database works, and it's very fast. I've compared it to Postgres and MySQL, and in most instances we're faster, and we don't need any indexes in order to accomplish that task. So have fun playing with it, and thank you very much.